Okay, we just now mentioned in this that Euler's formula, which is given by PCR is equal to pi square E I minimum divided by effective length square. This formula cannot be used for short columns. What formula should we use? So short, I mean basically long columns means like this. Long columns means like this. Very slender, and here you are applying a load P. Here you are applying a load P. This is long column. A short column means what? A short column means a very short like this. Have you done this? Have you done this test in UTM? A similar type of compression test. Have you done?
Yes, sir.
You have done, no? You have done this. You have applied load. Now we know that any material can take some yield stress, beyond which it starts to deform. So what is stress? What is the formula for stress? Load upon area. So if you want, suppose if you wanted P, then you can say that P instead of CR, which is called as the crippling. This stands for crippling. This stands for crippling. This stands for C stands for crushing. Because whenever it is short, it starts getting crushed. It is not crippling. Crippling means what? Crippling and buckling is same. Crippling and buckling is same. When this axis starts to move to sidewards, because this load and this axis is not perfectly aligned, however we try, it will get misaligned at some point. Okay, so it starts buckling to the sidewards. You can't somehow see that this axis is always in line with the load, so it starts to only compress. It will start to move like this, and here because of this distance, you will see that there is some force with this distance x that will also try to create a moment. So there is moment at this, there is stress due to bending, there is stress due to this perpendicular load, there are two loads, there are two stresses induced here, so definitely it is going to fail. Okay, so in this formula, that is PC due to crushing is given by sigma C into A, where sigma stands for the crushing load or the yield. You can also say that sigma Y it is, because that is at this point you can say that the metal has failed. Okay, the first formula is for what? Okay, first formula is for what type of columns? Long columns. The second one is for short columns. Now what about the medium length columns? Medium length means not too long, not too short. Something like this. Not too long, not too short. Now something like this. So what do you use? So now just we have to understand, so there can be a question in the internals or in the examination. What is the limitation with Euler's formula, and how does this Rankine-Gordon formula overcome this? So Rankine and Gordon were actually two engineers who were working actually as structural engineers. Maybe I don't know exactly, but they worked on the structures. They actually came out with a new solution. That means they found out that this cannot be used for medium length columns. For short, you can use this, but for medium length, you need a different formula. So they made this. So we need to understand that in the case of this, in the case of the Euler formula, whether you are taking the load, the Euler load, is it visible? The Euler load, this is LE by K. Now from where did this LE by K come? I'll tell you now. So PCR is equal to pi square EI divided by LE. Okay, so this I is equal to AK square, which is actually moment of inertia. Which is actually AK square. So which is nothing but this, you have seen I is equal to integral of y square dA, during the derivation. That's the same it is. So where K is called as the radius of gyration. So it's called the radius of gyration. So you use this formula here where is this. So when you substitute this, so then you can write this as pi square E A, and this K comes down, and you can write this as LE by K. So this is actually the load, or otherwise, if you actually bring this A this side, if you bring this A this side, then it becomes the stress. So if this LE by K, which is called the slenderness ratio, so you know that this I means larger the section of the beam, larger the section like this, larger the section of the beams, then I is larger. Okay, I is larger in this way than this way, and you can have larger and larger sections which will have larger I. So if this K is larger, then this LE by K will be larger. And for larger and larger sections, I mean LE by K, then the slenderness ratio is larger. That means it is more slender. Okay. So suppose if K is larger, then it will try to reduce this LE by K value. If LE is larger, then it will try to increase this LE by K value. So therefore, if you are saying this for this formula which I used now here, you can either plot for PCR or you can plot for sigma, both. You can actually plot for PCR, or you can bring this A here and then you can plot for sigma also. Both it is the same, because the equation is same. For actually short, for a very low value of LE by K. Now what happens if you are dividing this by 0? If you are dividing this value by 0, what would happen? It would become infinity. So that means very close to low value of LE by K. This says that it can almost take infinite loads. Is it possible? Is it possible that very short columns can take infinite load? No. But according to this formula, it feels that it can take almost infinite loads. But as you increase the value of LE by K, it starts going like this. Now what you are seeing is the graph that you have plotted for Euler's formula. What you have plotted is for Euler's formula. Okay, but this maximum amount of load that this short columns can take is limited by this. Because we know the yield stress here. So depending upon that, the maximum which can take is this. Now we want to come out with a new formula which is called as the Rankine-Gordon formula. The Rankine-Gordon formula will be somewhat like this. So that is Rankine-Gordon formula. So that means for long columns, this Rankine-Gordon formula will be almost the same as Euler formula. For short columns, it will be the same as this. So this is a better formula, because Euler's formula would completely go wrong for very short columns. So that means for very short columns, it would almost feel like it would take infinite load. So we are coming with the Rankine-Gordon formula now. Okay. So Rankine-Gordon formula overcomes this issues. So let us see what is this Rankine-Gordon formula now. Guys, I said for short columns we use this sigma C into A. For long columns we use this PCR. So PCR for crippling, PC for crushing. Okay. Now this is short, this is long, this is medium. Suppose if I am not using long or short columns, I am using a medium length column. It is as good as using both long and short columns in parallel. Something like this. I can actually imagine, you can imagine something like this. Imagine that you are supposed to take a load, you are supposed to take a huge amount of load, and this is the load. Now you are using a very long column here, and also a short column in parallel. So that is like the property of a medium column. So that means it behaves a little bit 50% like long column, 50% like short column. Now Now for this you know the formula. For this you know the formula. This is like it is trying to take the resist. I mean, it is trying to resist the loads like this. Okay, I want to go back to your PU physics classes. If you got actually, suppose if you got two resistances, R1 and R2, what is the equivalent? I mean, now what is the equivalent resistance? So R equivalent is equal to 1 by. Okay, so suppose you can write this as like this now. So can you write like this? So that means these are resistances. Resistances means what? Basically taking load. If they can take more load, that means they are able to produce more resistance. So here this taking load is basically means they are actually trying to resist by PCR and they are trying to resist by PC. Resistance is proportional to the load bearing capability. If I am able to resist more load, that means I am able to take, I'm able to produce more resistance. So now I can say that the equivalent resistance in this case is I have to equate this R1 and R2 the same as PCR and PC. Okay, so that is what I have to do now. So this is actually a very important concept of why this Rankine-Gordon formula came. Rankine and Gordon were actually two engineers. Those were two people who actually bought this new formula. So that formula is it visible up to here? Okay. Now I'll write this using this formula, using this concept. What I will do, this P equivalent, which I can write it 1 by P, that is the actual load for a short column. 1 by P, I'll write it as this, and this is R1, which is for a long column. So for long column I am writing it as PCR. For short column I am writing it as PC. Okay. So now once it is done, I am trying to erase this so that it is visible for you, and also I am in a comfortable position to write. Guys, so this 1 by P can be written as this. So you can write this as PCR into P and this PCR plus P, right now. So then you can actually rework on this formula. Then you can write this as PCR by P and then PCR plus P. Okay, now this P, let me see whether I just have to it is PC by PCR. Okay, I'll divide this whole thing by PCR. So I'll divide this whole thing by PCR. I'll divide by PCR both sides, numerator and denominator. Then this becomes PC. So this becomes PCR, cancels out, and this PC by PCR. PCR. Okay, you have done this. So we are trying to do some adjustments here, so to get a final equation. So then you know what is PC and PCR now. What is PC, guys? Basically, what is PC? So crushing load. So that is sigma C into A, and then 1 plus PC, that is sigma C into A, and PCR is nothing but this pi square A by L square. So pi square E I minimum by L square. Okay, now I can rewrite these equations as sigma C into A 1 plus sigma C into A divided by pi square E. So let me see what is. Okay, this A is not included. Okay, so pi square E and A, this is I. So I is nothing but, so there's confusion. So this is sigma c into a, this is this, and with the, that's in the denominator. So pi square e, and this LE can be taken. So LE is here. Guys, is this LE square? Yeah, this is LE square. This is LE square here. This is I can be written as, guys, what is I said just now, few minutes back. I said is equal to AK square. So there are actually two. For area moment of inertia, it is AK square. That is for mass moment of inertia, it is MK square. So I think we will see this in dynamics later. So this is I is equal to AK square for area moment of inertia. So let us substitute this I is equal to I now. So I is nothing but AK square. Okay. Now this A and A gets cancelled out. A and A gets cancelled out, and this K square can come down. Okay. So you're left with the equation sigma c into A, pi square E by, sorry, this is 1 plus pi square E. This is, okay, this, now this K has come here, LE by K whole square. Is this the formula? Yes. So you can write this, you can bring this above here, then it becomes like LE by K whole square. So can you invert this?
Yes, sir.
It's already LE by K square. Yeah. Okay, and finally write this equation as it is. Okay guys, now finally this pi square, so I missed here sigma c, this A and A got cancelled out, no? A and A got cancelled out. So pi square, so sigma c, pi square E, so this will be taken as constant here. So this will be taken as constant. Finally I will write the equation here. So finally I will write this equation. So P, which is actually the Rankine-Gordon formula, can be written as sigma c into A divided by 1 plus A into LE by K square. Okay, LE by K square. So where A is nothing but, it is pi square E divided by, sorry, which is sigma c divided by pi square E. So this will be taken as A. So this will be given in the numerical usually. Now this value would be given in the numerical. Okay, I'm really, okay, it is the way most numericals are given. So they will give you the value of A. They will give you the, here what is gone? A is gone, no? Sigma c, okay, sigma c, no, I think this sigma c will remain. Now the sigma c by A will remain. This is only remaining, okay? So this is called as the Rankine-Gordon formula, which you will use to solve numericals where the length of the column is not too long, not too short. So please, you have to remember this formula.